we are going to participate in an e-learning day in pre-calculus, and we're going to do that as we cover Chapter 7, Section 5 on double angle identities. First thing we should do is review some of the rules for today's lesson. As we go through this PowerPoint, you are expected to take notes on the information in the PowerPoints. It contains the various examples that cover the material you are expected to know how to do for double angle formulas. You may not have a conversation with me today during class. If you have questions, you can come back after school or tomorrow morning during contact time before school. But today in class, we are not having any verbal conversations. You do have to email me today during class at some point to tell me that A, you completely understand the lesson, everything is peachy keen, and you have no questions, or B, to ask questions. This email can come throughout the PowerPoint. You can stop the PowerPoint and switch to email and send me an email if you have a question on something, or you can just email me all your questions at the end. You must email me today during the lesson to verify that you have participated in today's e-learning activity. After you have taken notes, you are to do our homework. The homework will be given to you on the last slide of the PowerPoint. As I said, we are starting double angle identities today, which means that we need to learn our double angle formulas. There are 5 of these. The first formula is for the sine of 2 theta. That identity is 2 times the sine of theta times the cosine of theta. The second is for the cosine of 2 theta. There are 3 double angle identities for the cosine of 2 theta. Cosine squared theta minus sine squared theta, 1 minus 2 sine squared theta, and 2 cosine squared theta minus 1. All 3 of these identities are your responsibility. All 3 of these identities can be used at any point in time that you are being asked to evaluate a double angle identity. The first one tends to be the most user-friendly because it provides you with a common denominator immediately when working with fractions. The final double angle identity that you are responsible for is the tangent of 2 theta. That equals 2 times the tangent of theta divided by the quantity of 1 minus tangent squared theta. A few things you should note. At some point, you will be asked by verifying an identity that the sine of 2 theta equals 2 sine theta cosine theta, or any of the double angle identities for the cosine or the tangent of 2 theta. I'll give you a hint. These can be done using sum and difference formulas. I also want to let you know that at some point you will be asked to verify that your 3 double angle identities for the cosine of 2 theta are equivalent. Those can be done using your Pythagorean identities. Please again make sure that you take the time to learn these. Put them in your long-term memory banks. We are going to do 3 things with double angle identities today. We are going to simplify expressions that entail double angle identities that would be similar to verifying. We are going to evaluate expressions utilizing double angle identities. And we are going to find the values of double angle identities through the usage of triangles. First up, we are going to simplify double angle identities. Our responsibility when doing these is to identify a double angle identity hidden within the problem given. So we want to simplify 12 times the sine of x times the cosine of x. As you look at this, you'll notice that sine x, cosine x, that is part of a Pythagorean identity for the sine of 2x. So we will rewrite this as 6 times the quantity of 2 sine x cosine x. 2 sine x cosine x becomes the sine of 2x, and 6 carries down. And we have simplified this. This is simplified because we no longer have to write 2 trig functions. Our second double angle identity that we're going to use to simplify is 8 cosine squared x minus 4. Again, you'll notice that this looks similar to one of our double angle formulas for the cosine. So we will factor a 4 out of this and have 4 times the quantity of 2 cosine squared x minus 1. 2 cosine squared x minus 1 becomes the cosine of 2x, and we have the 4 in front. The second thing we're going to do is evaluate expressions using double angle identities. Please note that evaluate means that you will find a numerical value as an answer. And first up, we have 2 times the sine of 3 pi over 8 times the cosine of 3 pi over 8. 2 sine theta cosine theta is the double angle identity for sine of theta. So as we look at this, we can rewrite this. Notice 3 pi over 8 is in place of sine. So we have 2 times 3 pi over 8 is our angle. 2 times 3 pi over 8 gives us 3 pi over 4, and we are evaluating the sine of that, and we get out square root of 2 over 2. The next one we're going to do is cosine squared of 7 pi over 12 minus sine squared of 7 pi over 12. This is a double angle identity for the cosine function. So we have cosine of 2 times 7 pi over 12, which simplifies to the cosine of 7 pi over 6. And we find that value on our unit circle, which is negative square root of 3 over 2. And last up in the evaluate is a tangent problem. We have 2 times the tangent of 165 degrees divided by 1 minus the tangent squared of 165 degrees is not on your unit circle. That is a clue that we need to use identities. So we substitute in a double angle identity, so it's tangent of 2 times 165 degrees, which gives us the tangent of 330 degrees, which evaluates to negative square root of 3 over 3. Last up, we are going to find the value of each of your double angle formulas through a triangle. Notice that you're going to be given 2 pieces of information. You're going to be told what quadrant the triangle is in, and you're going to be given information to label the sides of the triangle. So our first step is to draw a picture using the given information. So again, we're given the quadrant. Between pi and 3 pi over 2 means we're down here in quadrant 3. And then you're given the information to label the sides. According to SOHCAHTOA, cosine is adjacent over the hypotenuse. It is up to us then to use the Pythagorean theorem to find the missing side. I'm going to do that on the next slide. So as we look here, we have the adjacent side of negative 2 and the hypotenuse of 3. We find the missing side with a squared plus b squared equals c squared. Our missing side goes down, so we find out that that side is negative square root of 5. Now our job is to find 3 things. We have to find the sine of 2u. Like I said earlier, you are expected to learn these identities, so I would suggest you write the formula every time you use the identity. So the sine of 2u is 2 sine u cosine u. And we work our way to the triangle. The sine is opposite over hypotenuse, and the cosine is adjacent over hypotenuse. So we have 2 times negative square root of 5 over 3 times negative 2 over 3. The 2 goes over 1, we multiply our numerators, and we multiply our denominators. And our answer is negative 4 square root of 5 all over 9. If you can reduce this, you should. If it needs to be rationalized, you need to do that as well. Next up is the cosine of 2u. Now, on the very first introduction of double angle formulas, you were given three identities, three forms of the double angle identity of cosine of 2u. All three of these should give you the same answer, and we're going to demonstrate that on this slide. First up, we're going to use our favorite, the cosine squared u minus sine squared u. Again, the values for the trig functions come from your triangle that we've drawn. The cosine of u is negative 2/3. That gets squared. The sine of u is negative square root of 5 over 3. That gets squared. When you square a fraction, you square the numerator and the denominator. So 4/9 minus 5/9 gives us negative 1/9 for an answer. No matter what formula we use, we need to get negative 1/9 as our answer. So if we try to use the 1 minus 2 sine squared of u, we should get the same answer. Let's see. So we have 1 minus 2 times negative square root of 5 over 3, the quantity squared. We square that and we get 1 minus 2 times 5/9. This is where this identity is a little bit more work than the first identity. In the first identity we have a common denominator. Here I do not, so I need to rewrite the 1 as 9 over 9 so that I can do my subtraction. 9/9 minus 10/9 gives us negative 1/9. So far, my statement that the two identities are equivalent is true. But will that statement be true for the third double angle identity of cosine? We have 2 cosine squared u minus 1. So again, we look at the identity and we need a cosine value, so we go to our triangle to find the negative 2/3. So 2 times negative 2/3 squared minus 1. We square the fraction, so we have 2 times 4/9 minus 1. And again, we got that 1, just like we did prior, that needs to be rewritten with that common denominator of 9. 8/9 minus 9/9 gives you negative 1/9. All three cosine of 2 theta identities will give you the same numerical answer. Last up, we have the tangent of 2u. Again, we write out the identity. 2 tangent u times 1 minus tangent squared u. We get our tangent value from the triangle. Tangent's opposite over adjacent, so square root of 5 over 2. So 2 times square root of 5 over 2 divided by 1 minus square root of 5 over 2, the quantity squared. We multiply in the numerator, that gives us square root of 5, and we square in the denominator to give us 5/4. 1 minus 5/4 gives us a negative 1/4 in the denominator. Remember, when you divide by a fraction, you change it to multiplication by the reciprocal, and we get a final answer of negative 4 square root of 5. Your homework assignment tonight is a MyMathLab 7.6. It is due Tuesday morning, March the 31st at 8:10 a.m. All work needs to be done on a sheet of paper. Make sure your name is on the top because you will be turning it in at the end of, or at the beginning of the class period. Please make sure that you take the time now to email me if you have not done so already before starting your homework. Thank you.